Okay, Algebra 2 students, we are back. This is section 7.5, the last section in this chapter. When I'm done with this, I will also be including a chapter review kind of puzzle and also a multiple choice version of a chapter test for you to just kind of practice on if you so choose. Again, none of this is for grade. It's just for you to see how well you've learned these 5 sections of chapter 7. So anyway, this will be the only quote unquote new section this week because we're done with chapter 7. So next week I plan on starting in on the next one. So if you remember in chapter 5, we have talked about sequences, we have talked about series, both arithmetic and geometric. So today we're going to talk about a particular type called a recursive sequence. If you look at the vocab here, a recursive rule gives the beginning term or terms of a sequence and then a recursive equation that tells how a sub n is related to one or more preceding terms. So how do you get from, or how do you get to the second term using the first one? How do you get to the third term using the second one, and so on? Kind of like we've already been doing, but now it's recursive. So it's going to take your answer and then do something to it and keep going. In general, rules for arithmetic and geometric sequences can be written recursively as follows. So arithmetic sequence, we know that we take the preceding term, and add d. Okay, remember d is the difference from one term to the other. On a geometric sequence, again, to get to the next term, we take the preceding term times r, or the ratio, if you remember. Okay, so arithmetic, you add d could be positive or negative. Geometric, you multiply the preceding term times r. Now, look down here at some of these examples. Example 1, it says evaluate recursive rules. Write the first 6 terms of the sequence. Okay, now, it gives you, on all of these, it has to give you 2 things. It has to give you the first term, because you got to have a starting point. And then it has to give you the rule. Now again, up until now, when we were just writing sequences and series, we always started at a 1, okay? On a recursive rule, you don't necessarily have to. They can give you whatever starting number they want you to use. So this one, you start with a 1 and then a sub n. So like the third term of your sequence would have the second term plus 3. The fifth term of your sequence would have the fourth term plus 3, and so on. But the only way you can get to a fifth or sixth term is to find the ones preceding it. Okay, so there's no hard and fast formula that you could find the 100th term. You're going to have to find the ones preceding it leading up to it. So if we're supposed to write the first 6 terms, this is the first one. And then notice they use this 1, and then it's 1 plus 3. And then they use the 4. They got 4. And then they use the 4 plus 3. That gave them 7. Then they use the 7 plus 3. That gives them 10. Then they use the 10 plus 3. That gives them 13. Then they use 13 plus 3. And then they get to 16 and so on. So it's recursive. Okay, that's what we mean. This 4 goes into here. This 7 goes into here. This 10 and so on. Okay, you have to use the preceding term to get to the next one. Part B is geometric. Okay, because we have a ratio out in front. So again, first term here is 1. So then we take 2 times 1 and we get 2. And then here's my 2. 2 times 2, we get 4. So then 4 times 2, we get 8. 8 times 2, we get 16. 16 times 2, we get 32, and so on. Okay, so again, you take the ratio times the preceding term to get the next term. Okay, so let's do that on some of these here for exercises for example 1, right? The first 6 terms of the sequence. So on number 1, I'm going to kind of do it over here on the left-hand side. A1 is 10, and then here's my rule. My rule is to take the preceding term and then subtract 2. So my A2 term is going to be 10 minus 2, or 8. My third term is going to be 8 minus 2, or 6. My fourth term is 6 minus 2, which is 4. Fifth term is 4 minus 2, which is 2. Sixth term is 2 minus 2, which is 0. So the first 6 terms of my sequence are those. Okay? Again, you're using the answer to the preceding term and then applying the difference or the ratio to get to the next one. Okay. So number 2, let's look at it. So again, we start, notice this is another example. We start with a 2, but then here's my rule. Okay. Now this one's a little different because it's the preceding term plus the term number minus 1. Okay, so let's kind of walk through this. So A1 is 2. They gave us that one. A sub 2 is going to be A sub 1, which is my 2, plus 2 minus 1. Well, that's going to give me a 3. Okay, 2 plus 2 is 4, minus 1 is 3. Now, my third term is going to be, again, my previous one, that's a 3, plus 3 minus 1. Well, 6 minus 1 is 5. Then A sub 4 is going to, I start off with my preceding term, that's my 5, plus 4 minus 1. 9 minus 1 is 8. My fifth term starts off with my preceding term, that's 8, plus 5 minus 1. Well, 13 minus 1 is 12. The sixth term, again, my preceding term of 12, plus 6 minus 1. 18 minus 1, 17. So here are my first 6 terms. Now, if you notice, the difference between the first and second term is 1. Difference between the third or second and third is 2. Difference between third and fourth is 3. Fourth and fifth is 4. Fifth and sixth is 5. Okay, so that's kind of slick. Now, number 3. Now we're into geometric recursive sequences. So here they give me, now notice this one starts with A sub 0. Okay, that's fine. It can start with a 0 or a 1. It really doesn't matter. First 6 terms of the sequence, though, they give us an A sub 0 because they don't really want the 1 included in the first 6 terms. The first 6 terms of the sequence would be A sub 1 through A sub 6. So, but we need the A sub 0 to get it started. So on this one, A sub 1 would be 3 times A sub 0, right? Which was 3 times 1, or 3. Okay. A sub 2, remember our ratio here is, our R is 3. So we're taking 3 times the preceding term. So I'm going to kind of scooch over here. 3 times 3 is 9. A sub 3 is going to be 9 times 3, or 27. A sub 4, sorry, I kind of write numbers wrong order. 3 times 27, which is 81. And actually, I misspoke. So I just kind of double checked. They did start with a sub 0. So they started with a sub 0, which was 1. So these would be my first 6. So I guess if we're starting with 0, then our first 6 terms are going to be 0 through 5. So 1, 3, 9, 27, 81, 243. Okay? So a sub 0 can count as our first term. I misspoke. Okay, fourth one. I'm just going to write these side by side. I hope you all can see them. Our first term here is 80. And then according to our ratio here is 0.5, 1/2. We're taking half of the preceding term. Okay, so the next term is going to be half of the preceding one. So what's half of 80? 40. What's half of 40? 20. What's half of 20? 10. Half of 10 is 5. Half of 5 is just 5 halves is probably what I would leave it as. For 2.5, I don't really care. And that's 6 terms. Okay, so I wrote the first 3 out in detail. Next one, once you kind of know what you're doing, you can just go from one to the next. Now, we can use the basic formulas to try to write the recursive rules. They give us the sequence, we write the rule. Okay, so the first thing that jumps out at me here on this one is that this is 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. So it looks like my D is 3. That is definitely an arithmetic sequence, okay, not geometric. So again, here's the general recursive rule for an arithmetic sequence. But remember, you got to have 2 things. You got to tell me the starting point and you got to tell me the rule. So here is what I would need for an answer. Okay, you got to give me the starting point. That's the a sub 1 equals 5. And then the recursive rule is a sub n equals a sub n minus 1, the preceding term, plus 3. Got to have both pieces. Okay, let's look at the backside. So we are going to be writing the rules. So again, you got to have 2 things for a rule. You got to have a sub 1, or you can start at a sub 0. I don't really care. Most start at a sub 1, but you can give me a sub 1 and then give me the rule. Okay, so first we got to be able to look at these sequences and figure out whether they're arithmetic or well, actually this tells us they're arithmetic. I apologize. I guess we'll do geometric here in a minute. So these are all arithmetic. So to get from one to the next, it looks like I add 2, add 2, add 2, add 2. So obviously my D is going to be 2. So the 2 things I need here for number 5 is that a sub 1 is 0, and then a sub n equals a sub n minus 1 plus 2. That would be my answer for number 5. Okay, general rule. Number 6, how am I getting from one to the next? It looks like I'm adding 1, plus 1, plus 1, plus 1. So my D is a 1. So again, I got to have 2 things. I've got to have my a sub 1, which is negative 3, and I've got to have my a sub n is a sub n minus 1 minus, oh, sorry. I looked at the wrong thing. A sub n minus 1 plus 1 plus my D. Okay, I looked up above and saw the minus 3 and wrote down the wrong thing. So that would be what I needed for number 6. Now, number 7. Again, got to figure out my D here. This looks like I'm adding, what, 12 each time? Looks like it. Okay, so obviously my D is a positive 12. So again, got to have 2 things. Got to have my a sub 1, which is 11. Got to have my starting point. And then a sub n is a sub n minus 1 plus 12. That's your recursive rule with a starting point. And number 8. Again, how do I get from one to the next? Looks like I'm adding 4 each time. Okay, so D equals 4. So again, got to have 2 things. Got to have your starting point. A sub 1 is negative 12. and you got to have your recursive rule. A sub n is a sub n minus 1. Again, that's the preceding term, plus 4. Okay? These are pretty straightforward. Okay, scrolling down. Now we're talking about geometric sequences. Remember, the general rule for geometric sequence is, for the recursive rule, is you take the preceding term times the ratio. Okay, preceding term times the ratio. So again, you need two things, like on this example. You need two things. You need your starting point and you need your recursive rule. So this would be your answer. Okay, starting point, your a sub 1 equals whatever your first term is, and then your recursive rule. Okay, now let's look at the exercises then for example 3. So write a recursive rule for the geometric sequence. So again, we've got to kind of go through here and figure out what our R is. I'll spit it out here in a minute. So to get from here to here, looks like we're multiplying by 2 times 2 times 2. So my R is going to be 2. So need two things again. Remember, I need my a sub 1 is 1. That's my starting point. And then my recursive rule is a sub n equals 2 times a sub n minus 1. So I've got to have both pieces of that. Okay. 10. To get from one to the next, it looks like we're dividing by 2. Okay, well, ratios, we can't really use division, but what we can say is times a half. Okay, times a half, times a half. I don't know if you can see that 1 over 2, it's kind of little. So again, got to have two pieces. Got to have my starting point. My a sub 1 is 40. And then my recursive rule. My ratio is 1/2 times a sub n minus 1. So got to have starting point, got to have recursive rule. Okay. Next one. Looks like times 6. Okay. So again, my R is 6. So we've got to have my starting point. A sub 1 is 3. A sub n is 6 times the preceding term, a sub n minus 1. Got to have both pieces. And then last one. Now, we've talked about this before, and we've had an example of it right above, but where your signs alternate, your ratio is going to be a negative when your signs alternate, because remember, negative times negative gives you positive, positive times negative gives you negative. So this looks like we're doing times -2 times -2. So it looks like my R on this one is a -2 because my signs keep swapping. Okay, so again, got to have starting point. A sub 1 is 1. And my recursive rule is a -2 times the preceding term, which is a sub n minus 1. Okay, so those are geometric sequences. Now, last example, an exercise, is kind of special case. There are times when our sequence will depend not only on the preceding term, but also on maybe 2 of the preceding terms, like the first preceding term, the one right behind it, and 2 behind it. So the preceding term behind the preceding term. So it could occur, or could rely, I should say, on 2 preceding terms. So look at this example. It says write a recursive rule for the sequence 1, 1, 4, 10, 28, 76. So here's what they did. It looks like, as I look down through here, so if I add these together, I get 2. Okay, that's a plus. But then if I take 2 times 2, I get my 4. Okay, well, let's try that on the next 2. So 1 plus 4 is 5. Okay. 2 times 5 is where I get 10. Okay. So again, this gets a little tricky. 4 plus 10 is 14. 2 times 14 is 28. So again, some of these require us to use the preceding two terms to get the job done. So that one was kind of tricky to see. So on that one, look at all they've had to write here. They have to write the first term, they have to write the second term, then they have to write the rule. So the preceding term is the n-1 term. The two preceding terms, or two terms in front of it, is the n-2 term. So it's a sub 1 is 1, a sub 2 is 1, a sub n is 2 times the sum of a sub n-2 plus a sub n-1. Okay. Ooh, that was kind of tricky. Let's look at exercise for example 4. Okay, let's look at this one. So this one's a little more straightforward. It looks to me like 3 times 4 equals 12. You see that? 4 times 12 equals 48. 12 times 48 equals 576. Okay, so that's what I see. So again, you can kind of write that out. 3 times 4 equals 12. 4 times 12 equals 48. 48, where did I say? 3 times 4 equals 12. 4 times 12 equals 48. Sorry, let me write it in the same order. 12 times 48 equals 576. Okay, so we're taking the preceding two terms and multiplying them. So I need a couple of things. Anytime I'm going to require two preceding terms, then I have to write down the first two terms of the sequence. So a sub 1 is 3 and a sub 2 is 4. Now, you could technically say a sub 0 is 3 and a sub 1 is 4. Okay, I don't care as long as you start at a logical spot. Then we need our recursive rule. So our recursive rule says that a sub n is going to be a sub n-1 times a sub n-2. We are going to multiply, got that dead spot, so let me scroll here. We are going to multiply the two preceding terms together. A sub n-1 times a sub n-2. This is what I would need for my full answer. So if you're going to require two preceding terms, then you got to label the first two terms. If you had some kind of weird sequence that did something with the three preceding terms, then you'd have to start off giving me the first three terms of the sequence. Okay. All right. Let's move on and look at practice A. Okay, practice A, let's do a couple of these. 1 through 6, it says write the first 5 terms of the sequence. So first of all, number 1 is a basic arithmetic sequence. How do I know that? Because we are just adding 4 to get from one term to the next. So the first term is 2. Add 4, you get 6. Add 4, you get 10. Add 4, you get 14. Add 4, you get 18. That's all there is to it. Those are the first 5 terms of the sequence on number 1. Okay, they give you the starting point already. Number 4 is kind of a menagerie. It's got a bit of both because it's got a ratio here, okay, and a difference. Okay, so we're going to start off with a -3. That's our first term. Well, then we're going to take 2 times -3 plus 5. Well, 2 times -3 plus 5, -6 plus 5, -1. Okay, then we're going to take 2 times -1 plus 5. 2 times -1 is -2 plus 5 is 3. Then 2 times 3 plus 5. 6 plus 5 is 11. Okay. And 2 times 11 plus 5. 22 plus 5 is 27. So these are the first 5 terms of the sequence. Okay, I hope you see that. Look at number 6. This is one of those special ones that's going to use a couple of preceding terms, because again, it starts off by giving us 2. Okay, so if a sub 1 is 1, a sub 2 is 8, it looks like our rule here is we're just adding the 2 preceding terms. So 1 plus 8 gives me 9. 8 plus 9, 17. 9 plus 17, 26. Okay, that's my first 5 terms. Now, I don't know why I'm writing them vertical instead of horizontal. It really makes no difference. I think I started off writing them vertical thinking I was going to have to write the formula next to it like I did on number 4, but I think those were easy enough to see. Okay, 7 through 14, write a recursive rule. So now we're not writing the terms, they're giving us the terms, we have to come up with the rule. It says, whoops, the sequence may be arithmetic, geometric, or neither. So we've got to kind of look at some of these, okay? So let's look at number 7. Number 7 looks straightforward enough here. We are going to, looks like just add 3 each term. You'll see that? So this one, our D is 3. So again, to find your recursive rule, if it's just something very straightforward like geometric or arithmetic, you just follow the basic rule, but you've got to give a starting point. Okay, so our starting point here, our first term is a 2, and our recursive rule is we take the preceding term plus 3. Okay, I hope you all can see that. Okay, number 9. Number 9 here, we've got, looks like times 5. Oh, actually not times 5, times negative 5. Do you all see that? So 4 times negative 5 is negative 20. Negative 20 times negative 5 is positive 100. So it looks like our R is a negative 5. Okay, so again, got to have a starting point. That would be my A1, which is 4. And then my recurring, A sub n is negative 5 times A sub n minus 1. Okay, so on that one, our ratio, again, because the signs flip-flopped, ratio was a negative. Wanted to look at 14, because it looks a little weird. When I looked at 14, I'm looking at it and going, okay, 1 plus 3 is 4, but then 4 plus 3 is not 3. And then I think geometric, so I'm thinking, okay, 1 times 4 is 4, but 4 times 4 is 16, so that doesn't work either. So this has got to be one of those weird ones that kind of relies on more than one preceding term. So first thing that jumps out at me then is that 4 minus 1 is 3. Okay, well, then if we go to the next one, if I look at the negative 1, how did I get negative 1? I took 3 minus 4 is negative 1. Okay, that's kind of a pattern. I'm taking the one just to the left of us minus the one to the left of it. Okay, so let's see if that keeps going. So now to get to negative 4, I'm taking negative 1 minus 3 gives me negative 4. Yep, that works. To get to negative 3, I'm taking negative 4 minus a negative 1, which is negative 3. Minus a negative 1 is plus 1, so that works. So that's my pattern, if you will. So on these, remember, I got to name 2 preceding terms. So I got to name the first term, and I got to name the second term. Then I can say my rule is that I am subtracting the one right behind me minus the one behind it, or the one 2 behind me, maybe I should say. Okay, so I'm starting off with the term right behind me. So if that's the third term, then that's the second term minus the first term, which would be 2 behind me. Okay, I hope you all can see that. So this is 14. Okay, so got to name, if you're relying on 2 preceding terms, then you have to name the first 2 terms of the sequence. A sub 1 is 1, A sub 2 is 4, and then in this case, A sub 3 would be the A sub 2 term minus the A sub 1 term. And then A sub 4 would be A sub 3 minus A sub 2. A sub 5 would be A sub 4 minus A sub 3, and so on. Okay, you got to kind of play with it in some cases. Now, the next section, we didn't see any on the study guide written this way, but it's just another way of writing them. They're kind of using function notation, but it's still a recursive rule. Okay, so I just wanted to make sure you all understood the writing this way. So this is the same as telling us, well, I'll tell you what, let me rewrite it. This is the same thing as saying like A sub 1 is 0 and A sub n is A sub n minus 1 plus 3. It's the same thing. Okay, same thing. They're just kind of writing it in function notation. Quite honestly, I'm not a huge fan of this. I think it's too easy to get misconstrued. But my first term, in this case, these, you'll notice they all, well, actually, let me back up. Notice that these all start with x sub zeros. Okay, every one of these starts with x sub 0. So I really shouldn't have written it this way. So the first thing I need to find is the first term, because x sub 0 is not the first term. That's why I don't really like these, because they're confusing. They're too hard to misconstrue. So let me write it this way. Let me say that x sub 1 is going to be x sub 0 plus 3, which in this case is x sub 0 is 0, so 0 plus 3 is 3. X sub 2 is going to be 3 plus 3, which is 6. X sub 3 is going to be 6 plus 3, which is 9. So if they want the first 3 iterations or the first 3 iterates of the function for the given value, that's what they're talking about. Still recursive. You're taking the answer to the first set and putting it in the next function. Okay, so essentially, I had written this incorrectly earlier. I would have rewritten this as like a sub 1 equals 3, and then a sub n equals a sub n minus 1 plus 3. Okay, that would be another way to write it. But the first 3 iterates, or I always call them iterations, was 3, 6, and 9. Okay, the sub 0 doesn't count as the first one on these. Let's look at 18. So to get to my x sub 1 term, if you will, so my x sub 1 term is going to be 3 times negative 4 plus 5, okay, which is negative 7. My second term, x sub 2 term, if you will, is going to be 3 times negative 7 plus 5, which is negative 16. And my x sub 3 term is going to be 3 times negative 16 plus 5, which is negative 43. So the first 3 iterations are those, negative 7, negative 16, negative 43. Okay, so you use the x sub 0 to get your first one. And then again, it's still recursive. You're using the answer from the first one to plug in to get the second. Answer from the second to plug in to get the third. Okay. All right, hope that helps. I'm just going to kind of get you started on the next couple here, the word problems. So on January 1st, 2006, you have $100 in a savings account that earns interest at a rate of 1% per month. Now, 1% is 0.01, okay? But that's the interest. It also keeps the original balance. So it's going to be 1.01. That's our rate, okay? If you go to the store and buy something and there's 8% sales tax, you're taking your total times 1.08. Okay, it's the same thing as taking your total times 0.08 and then adding it back to the original price. It's the same thing. Because this 1.01 is essentially saying you're taking 100% of the price plus 1% with the interest, okay? Or 100% of the investment plus 1% interest. That's what that means. And then you also deposit $75. So this would be like D equals a positive 75. So you got two things going on. You've got a rate working on it, plus you have a deposit each month. Okay, so it says write a recursive rule for the account balance at the beginning of the nth month. So first of all, our first month says we started off with $100. Got to have a starting point. Okay, then our nth month, A sub n, would be 1.01 times A sub n minus 1 plus 75. Okay, so we started with 100, and then at the beginning of every subsequent month, we're going to calculate the interest, which is the 1.01, and we're going to add the $75 that we put in the last day of the previous month. Okay. So that would be the answer like for number 23. Now, I'll let you finish the other one. 25, it says you buy a $500 television set on a layaway by making a down payment of $50. You will then pay $30 per month starting the next month. Now, a couple things I want to point out that have been sticking points in the past is up here they're asking for total amount of money paid. Down here, they're asking how much you have left to pay. Okay, so be careful. Okay, so on number 25, again, down payment of $50, that would be my starting point. Okay, it says, and then you pay $30 per month. So my recursive is, I'm going to take the subsequent month and I'm going to add $30 to that, to the amount of money paid on the television. I start off paying 50, then I'm going to take the previous month and add another 30. Take that, add another 30. Take that, add another 30. Okay. All right, I'm going to stop there. So that concludes section 7.5. I want to remind you that I am also going to post a like multiple choice version of the test just for you to kind of check yourself. There will also be some Delta Math assignments, okay, that I have posted already. And there's also a chapter review game. It's like a little crossword type thing, but I'll post all of that. But this will be my last video for chapter 7. All right? Okay.